Bismillahirrahmanirrahim. Today I'd like to talk about adding and subtracting radical expressions, or expressions that have the square root or the radical sign. Before we do this, we have to review the concept of like terms. If you recall, 3x squared and 12x squared, these were like terms, and we had defined like terms as terms that have the same variable, like this, in this case x, to the same exponent, which in this case it is 2. So these were like terms. Even a small modification here, such as 3x squared and 12x, these would not be like terms. Although we have the same variable here, we don't have them to the same exponent or the same degree. Therefore, when adding and subtracting algebraic expressions in general, we were mindful of like terms. And we had defined previously that these were the same variable and to the same exponent. And when we're dealing with radicals, we have another dimension to this, or an added component to this. That is, when adding and subtracting radical expressions, you have to make sure that the variables are the same, and you have to make sure they are to the same exponent, and you have to make sure that everything that's under the radical or the radicand is the same. So before we add and subtract any radical expressions, we have to be very confident in our understanding of what it means for two algebraic terms to be like terms. We understood from before again that for two algebraic terms to be like terms, the variables had to be the same and they had to be to the same exponent. And now we're going to add to that, because now we're dealing with radical expressions, in that everything that's under the roof of the radical, like here, has to be the same. As an example, 3x squared and 12x squared, these are like terms. But as soon as you add, for example, square root of 3 over here, and then square root of 5 over here, these are no longer like terms, so to speak. Now, to be fair, really, that's not technically true, because these two are, in fact, they have the same variable, the same exponent. And if you were to combine, you can combine together by factoring out the x squared and whatever numbers that you can. But you can't, combine them into one big number, for example. So this concept of like term, it helps to think of it in this way. Now, if, on the other hand, you had 3x squared times the square root of 3, and then you had 12x squared times the square root of 3, now these would be like terms, because now you have the same variable to the same exponent, and in addition to that, the radical is the same. On the contrary, a small modification such as this, 3x squared times square root of 3, and then 12x squared times square root of 3x, these are no longer like terms because clearly, obviously, the variables are not the same. So if you think of these radical expressions as whether they're like or not like, then you can add and subtract them reasonably easily. Thus, in summary, we elaborate on our knowledge from before that two terms are like terms if they have the same variable, and those variables have the same exponents. And now we add that, and whatever's inside the umbrella of the radical sign or the radicand is also the same. So let's practice some. 3 square root of 5 and 7 square root of 5. Now these you can add. See, if I said 3 square root of 5 plus 7 square root of 5, now these two you can add. Now this would be analogous to 3x plus 7x. Then the answer here simply is 3 square root of 5 plus 7 square root of 5 is 10 square root of 5. Just like 3x plus 7x would be 10x. Now 3 square root of 5 plus 7 square root of 5 is not like 10 square root of 10 or something like that. Right? So you just add the coefficients, but you don't add the radicand or whatever's under the radical. How about this one? 3 square root of 7 minus 8 square root of 7. Now you can subtract these as well, because again, the radicand or whatever's under the roof of the radical sign is the same. So it's like 3x minus 8x. So this would be 3 minus 8 is negative 5 square root of 7. Now you simply subtract the coefficients, and then you leave the radicals alone. How about this? negative 6 square root of 3 minus 4 square root of 3 plus 7 square root of 5. Now here, these two you can add. So this becomes negative 6 minus 4, that is negative 10 square root of 3 plus 7 square root of 5. Now you cannot simplify this any further. How about this one? Negative 9 square root of 15 plus 10 square root of 15. Now again, you can add these because again, the radicand is the same, or whatever's under the umbrella of the radical sign is the same. So negative 9 plus 10 is 1 square root of 15, or simply square root of 15. Okay, now consider the following example. If you look at this superficially, you would say, well, you can't add these because the radicand, or the stuff that's inside the radical symbol, is not the same. But wait, perhaps we can simplify these, right? We can do the prime factorization and everything, and maybe simplify them and see what happens. Okay, so let's do that. So 18 we can do prime factorization. That's 2 times 9, and that's 3 times 3. So this can be rewritten as 3 times the square root of 2 times 3 times 3. And then 12 is 2 times 6, and that's 2 times 3. So we can rewrite this expression as 3 times the square root of 2 times 2 times 3. And finally, 27 is 3 times 9, and that's 3 times 3. And that can be rewritten as 2 times the square root of 3 times 3 times 3. Now here we make sandwiches, right, so to speak. You can simplify these. So this becomes 3 times 3 square root of 2. And here we have 3 times 2 square root of 3, because these two can come out. And finally over here, 2 times 3 square root of 3 over here. This last third over here, that needs to remain inside. And this becomes 3 times 3 is 9 square root of 2 plus 6 square root of 3 plus 6 square root of 3. And now you can see that these two you can combine. And then you would have 9 square root of 2 plus 6 is 12 square root of 3. And you can't simplify this any further, and this would be the answer. Okay, how about this one? Well, again, you see, none of the radicals are the same, so you would think that you can't combine them. But before we give up, we have to simplify these radicals. Well, you can't really simplify this, but here 20 can be simplified. That's 2 times 10, and that's 2 times 5, right? So that can be simplified. How about the 8? That's 2 times 4, and that's 2 times 2. So in simplifying this, we can't simplify the first term at all. That's negative 3 times the square root of 2. And the second term becomes the following. So you can take these two out. Those are 2 slices of bread. They come out as one sandwich, right? So that becomes 3 times 2. And then what remains inside is this 5 over here. That's 5 remains over there. And negative 3. And again, these two will come out. That's negative 3 times 2. And what will remain inside is this 2 over here, 2. And further simplifying this, you get negative 3 times the square root of 2, plus 3 times 2 is 6. Last time I checked, that's square root of 5, minus 6 square root of 2. Now you can see that this and these are like terms, so to speak, or they can be combined. So negative 3 square root of 2 minus 6 square root of 2, that's negative 9 square root of 2. See, when you add and subtract these, you do nothing to whatever's inside. You do nothing to the radicand, okay? You just add them like you were adding minus 3x minus 6x. That's negative 9x, right? So similarly, it's negative 9 square root of 2 plus 6 square root of 5. And that's it. You can't simplify this any further, but that certainly looks better than what we had started out with. Inshallah, next time we shall elaborate on this and do some more examples. Until then, as-salatu was-salamu ala rasulillah, walhamdulillah rabbil alameen. Assalamu alaikum.